We'll now look at the addition rule from probability. And we'll start by discussing mutually exclusive events. We say two events are mutually exclusive if they cannot occur at the same time. As an example, if I'm rolling a dice, I cannot roll both a 4 and an odd number at the same time by rolling a single dice. Therefore, those events are mutually exclusive. If I look at a university and I look at a random student and I look at the event of if they are female and if they are a junior, those would be non-mutually exclusive events because I can have someone who is both a junior and a female. So we have two addition rules for probability, and we'll start with the first of these. If we have two events that are mutually exclusive, the probability of A or B is equal to the probability of A plus the probability of B. We may also see this using this notation here. It looks like a U, and it actually means union. It's another way to represent A or B. Therefore, if our events are mutually exclusive, all we need to do is add the two probabilities. Let's consider a standard deck of cards. If we draw a card at random, we want to know what is the chance of drawing either an ace or a queen. Well, we'll start with the probability of an ace. There are 4 possible aces in the deck and a total of 52 cards. If I look at the queen, there are also 4 queens in the deck and a total of 52 cards. And our rule says we just need to add these. This gives us 8 over 52. Probabilities can be represented using decimals, fractions, or percents. So another way to write this, we could write it as a reduced fraction, 2 over 13. We could also write it as a decimal, 0.154, or as a percent, 15.4%. Any of these 3 answers are fine. Next, we'll look at the chance of drawing a face card or a 7. If I start with the face cards, once again, there's still 52 cards in the deck. Our face cards are our jacks, kings, and queens. There are 4 jacks, 4 queens, 4 kings, for a total of 12 face cards. For the 7, we have 4 sevens out of 52 cards. So this gives us a total of 16 out of 52. Once again, there are several ways to write this. We could write it as 16 over 52, or 4 over 13, or 0.308, or 30.8%. Any of these answers are fine. As our last example, we'll look at the chance of rolling a 5 or something less than 3. We'll consider a standard 6-sided dice. The probability of rolling a 5 would be 1 out of 6. The probability of rolling something less than 3. There are 2 numbers on a dice less than 3, 1 and 2. Therefore, 2 out of 6. This gives us a total of 3 out of 6. We could also write it as 1/2, or 0.5, or 50%. We'll now look at our second addition rule. Our first one only dealt with things that were mutually exclusive, so now we'll consider things that are not. If A and B are not mutually exclusive, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. The idea is I'm going to look at the first event, see how many different ways it could happen, then look at the second event and think of how many different ways it can happen, and then we realize that if we looked at the times A and B could happen together, we've now counted them twice, once for A and once for B, so we need to subtract one out. You may also see this as P of A union B, like we had before, is the probability of A plus the probability of B minus the probability of this symbol. And this is A intersect B, and is another way to represent the AND. As our first example, let's consider the chance of drawing either a diamond or a jack. If I think of a diamond, this is a quarter of our deck. In particular, there are 13 diamonds in our deck, at a total of 52. If we consider the number of jacks, we know there are 4 out of 52. And then we realize that we have a diamond card that is a jack. So we need to subtract that out because we have now counted it twice. Therefore, I have 13 plus 4 minus 1, which would be 16 over 52. And then we can write this several different ways. We have written as a reduced fraction 4 over 13, as a decimal 0.308, and as a percent 30.8%. Now let's look at the chance of drawing either a black card or a face card. Well, if I consider the black cards, that's half of my deck, and since there are a total of 52 cards, this means 26 out of 52 are black. As we've just discussed before, we have a total of 12 face cards. Well, half of those face cards are also black, so we've counted them twice, and we need to subtract them out. 26 over 52 plus 12 over 52 minus 6 over 52 is a total of 32 over 52. Once again, we can write this several different ways. A reduced fraction is 8 over 13, a decimal 0.615, and a percent 61.5%. As our last example, we'll look at the chance of drawing either a red card or a king. The red card, well, there are 26 out of 52. There are 4 kings, and 2 of those kings are also red cards, so we need to subtract that out. This gives us a total of 28 over 52. As a reduced fraction, this is 7 over 13, a decimal 0.534, and a percent 53.4%.